Alright, CNT125, Chapter 10, we're moving on to the topic of ACLs, access control lists. The access control list acts like a filter to permit or deny traffic. And this can be permit or deny traffic leaving your network or permit or deny traffic coming into your network. It might even be a permit or deny traffic from one part of your network to another part of your network. Okay, so this acts like, they use this example in the book a bunch, a bouncer in a nightclub. It's going to check basic information and say yes or no. You know, hey, can I see your license? Yeah, it looks like you're 21. Go ahead, go and have a good time. It can't check everything under the sun, but it can check some basic stuff. So it's kind of like a little basic checkpoint. By manipulating routers and switches, I can have devices sitting in my network, either in my network or at the edge of my network, helping with this filtering process. And I can control traffic through my routers and layer 3 switches and firewalls with things like access control lists. Remember, security is not a one deal thing. It's not a one, I put a firewall in and I'm done. I need to do multiple things. This is another piece of the puzzle. This is another tool in my drawer of things I can do to filter traffic or permit or deny traffic. That's what your access list is. We're going to do these in our firewall, and we're actually going to do these in our router too, just to kind of a little heads up. Our router's main function is really to examine packets and determine where they belong by IP address. But I can have some security done on things like my switches and routers. Switches can implement VLANs, kind of containing users, meaning you're not going to leave this fenced in area. And I can also, on my routers and layer 3 switches, put on access lists to say, well, where are you trying to go? Yeah, go ahead. Or where are you trying to go? No, sorry. Okay, so this can add a layer of security, putting an access list on. Routers can forward and deny traffic, and basically acts like a filter to pass or deny traffic. Absolutely. Some variables that an access list has. I can permit or deny traffic on an access list based on the following things. It could be a network layer protocol like IP or ICMP. So I can say, yes, you're trying to go to this IP, go ahead. Or you're trying to go to that IP, no, you can't. Or you're trying to come from this IP? No. You're trying to, etc. I can, where you're coming from, where you're going, I can look at, hey, where are you trying to go? Yes. Where you're trying to go? No, etc. I can also do this on transport layer protocol, TCP or UDP. Remember, every application has a TCP port number associated with it. So I can now say, okay, what type of program are you trying to run? What kind of application are you trying to deal with? You're trying to deal with Telnet? No, get out of here. You're trying to do SSH? Okay, where are you trying to go? Okay, that's all right. Or, you're trying to do SSH? Where are you trying to go? No, get out of here. You're outside my network. Go away. Okay, so I can do these all by port numbers, permitting and denying certain types of traffic. I can do it by where it's coming from. What IP address is it coming from? You're coming from this part of the network? Go ahead. You're coming from the wireless part of the network? No, get out of here. I don't know who you are. Where are you trying to go? You're trying to go out to the internet? Okay, fine. You're trying to go to where my servers are? No, I don't think so. So I have a whole bunch of variables I can use to mix and match and put together a filter list. Yes, you can. No, you can't. So when a router receives a packet, it's going to examine the packet. It's going to refer to the access list for permit or deny criteria. If it matches, it might drop it or it might turn around forward it, depending on how the access list is written. If the packet does not match any criteria, the packet can be dropped if we're not careful. There's an implicit deny rule at the end of an access list, meaning if I don't explicitly say, yeah, go ahead, the access list is going to say, no, you didn't allow it, so I'm going to deny it. So if I write a rule that says, okay, if you're wearing red sneakers, you're allowed to come in my room. If I don't say anything else, any other color is not allowed, because I did not say, well, blue is also allowed too. So if I wrote a rule that said blue and red are allowed, okay, any other color sneaker is not allowed in the room. So I have to be careful. There's an implicit deny on the end. The reason that's done is if I forget, it's at least covering my butt. If I forget to say, well, no, definitely no, orange sneakers are definitely not allowed, it's going to do that for me because I have not permitted them anyway. So it's really there to cover my butt if I forget something. But it's one of those that can cause me a problem because I might have forgotten to permit something. They use this little picture in here to show you. I write a series of rules. As traffic comes in, I see the first the line of code, if you will, to either permit or deny. Permit it, I'll move it on. Deny, no. If it doesn't match, it's going to go to the next test. If it doesn't match, it's going to go to the next test. And it's basically a list of permit or denies. And if something matches, it's either going to permit it or throw it out. But if it doesn't, eventually it's going to throw it out. So it's a process. It's a process. ACLs may be associated with inbound or outbound traffic. And this is kind of like the whole, if I have a security guard at the door, let's say I employ a security guard to stand at the door of our CNT lab room. I might give him two different rules. I might say, hey, Mr. Security Guard or Miss Security Guard, could you check the bags coming into the room for me? And permit or deny soda. I might actually say, hey, I want you to deny any soda coming into our room. So they're going to check that as you guys are coming into the classroom. But I can also turn around and write a second rule saying, hey, Mr. Security Guard or Miss Security Guard, as people are leaving the room, can you check the following? I want you to deny routers. So if they're trying to unbolt a router and take it out of the room, I want to deny them leaving the room with a router. And that would be a different rule. Up here is one permitting or denying stuff coming in, like soda coming into the room. And the other one is a separate rule of checking backpacks for routers leaving the room. So as I write an access list, I have different ways I can write it to permit or deny traffic going a certain direction. That's something else to keep in mind. In a warehouse, I might make sure that I might have a security guard that says, hey, make sure they're not bringing any kind of weapons into the place. And also, I'm going to have the security guard make sure they're checking the bags, make sure they're not taking any product out. Maybe it's, a warehouse full of chocolate bars or something. I'm making sure they're not taking chocolate bars out in their lunchbox on the way out. Okay, so I have different rules I can write, different criteria, and I also have different directions I can apply these. And again, it's all following this format. All right, so if I write an access list that actually says, okay, deny Telnet, deny FTP, but then permit anything left, and an FTP packet comes into this access list, it doesn't match this Telnet criteria. Nope, it doesn't match. It's going to keep going. Once it hits the FTP, it actually says, hey, deny this FTP. It's going to get thrown out. Done. Meanwhile, if I have this rule here, and I have a chunk of HTTP traffic, the first criteria, it's Telnet, nope, it doesn't match that. FTP, nope, it doesn't match that. Out here, permit IP, well, HTTP is part of IP. I now say, okay, permit IP or HTTP traffic, hey, it's permitted to go along its merry way. So, an access list almost has to be written almost as a process to make sure you're permitting and denying the right thing. And there might be some trial and error when you put it in place to make sure it's working correctly. The access list command is the one that you actually use to write your access list. And here's the syntax for it. Access list, I give it a number. I number these. I permit or deny. That's the first thing I say. I'm either going to permit traffic or deny it. The protocol I'm looking for, this could be TCP, UDP, IP. The source, what source network. Destination, where is it going? And then according to what type of port, whether it be SSH traffic or Telnet or port 80 for HTTP. That is my syntax. Now, when I write the access list, when I go to apply it, I need to identify the interface that's going to go on, and I'm going to say, hey, apply this access list coming in or out. Again, think of that security guard example standing at the door of our classroom. Which way do you want this access list being done? Do you want to check for soda coming in the room, or do you want to check for routers leaving the room? Okay. So if I want to deny Telnet traffic from entering the router from the internet, so I'd have Telnet traffic coming from the internet, somebody trying to hack into my network, it's going to come into this interface and I want to stop it right there. So I want to put a rule right there that says, hey, don't get into my network. What I might write is I might write access list 102. I'm going to deny TCP traffic, as Telnet is a type of TCP port number, if you will. equal to, I'm jumping out here at the end, equal to 23, so TCP equal to 23, TCP equal to Telnet, and I'm going to say coming from anywhere in the world, going to anywhere in my network. So I'm making it very wide, saying, look, if you're trying to Telnet, I don't care where you're coming from, I don't care where you're going, no, this router will stop that traffic. The next line of my access list then says, okay, I'm going to permit any remaining IP traffic coming from anywhere going to anywhere. Now, I might not realistically want to do that. I may not want to let people try to SSH into my network, but that I'm keeping this very simple at this point. This rule will stop Telnet. And then I turn around and I apply that onto interface Ethernet 1. That's this interface right here. And I say, okay, IP access group 102, because that's the number I gave. I'm going to apply that to the traffic coming in. So right here, I'm going to apply that to the traffic coming into that port, coming in from the internet in. And that will stop my Telnet traffic coming in from the internet. If I want to deny FTP traffic leaving my network, I would do access list 102 deny TCP equal to FTP. And you'll notice the next line equal to FTP data because FTP uses 20 and 21. So I need to write for both port numbers there. I'm going to deny TCP equal to FTP and FTP data coming from anywhere, going to anywhere. I don't care where you're coming from or where you're trying to go. I'm going to deny it. And then reminder at the bottom, IP any. Again, I might further limit other traffic, but this will permit any other traffic through. In this case, interface Ethernet 0, this guy right here. And I'm going to apply that IP access group 102 coming in. So in this case, there's traffic coming this way into the Ethernet 0 interface. Okay, that would deny my FTP. Now, I can also filter this based on the network that it's that's coming from or going to. And I can do that with my Wildcard Mask. The Wildcard Mask, we've done this a little bit with OSPF. Wildcard Mask says, okay, anything is a 0, I'm going to pay attention or match that bit. 1 says, I don't care or I'm going to ignore it. Okay, so if I'm going to deny FTP, so access list 102.1 deny TCP equal to FTP. Okay, so that we all recognize. And even access list deny TCP right here equal to FTP data. There's the 20 and 21. Okay, that's all familiar. Now, the next step is, before I said any and then any. Well, right now I'm going to put the source network. I'm going to put the source network saying, hey, I want to deny traffic coming from a source network. And I'm going to deny it going anywhere. So from here, I'm going to deny from here going to anywhere. And now if I look a little closer, I'm saying 192.168.10. So I'm saying this subnet, please deny this subnet the capability to FTP. And over here, instead of the subnet mask, I'm doing the inverse mask, if you will. I'm doing the wildcard mask. And I'm saying, okay, match 192, match 168, match 10. Match those 3 octets. If they're trying to come from 192.168.10, they're not allowed. And out here, 255 is all ones. So basically ignore. I don't care what node. Anybody coming from this network is going to be denied. Anybody coming from this network is going to be denied. And then I permit the rest of the traffic. Interface Ethernet 0, IP access group 102 in right here. So I'm going to deny, this will actually deny 10.0 traffic to FTP, but these guys right here will still be able to FTP. Okay, so that actually denied that particular subnet or that portion of the network. With Telnet, I want to deny Telnet from a certain group. In this case, I want to deny Telnet from the 192.168.20 network. So deny TCP equal to Telnet. 192.168.20 network .0 wildcard mask 000. Pay attention to 192.168.20. 255 says I don't care what node, and that will deny Telnet to that particular subnet. So that's how I start applying all those little variables to make my access list more usable or more granular to get down to the piece that I truly want to deny. We are going to do these on our firewall and on our router, so hopefully by that point they'll start clicking a little bit more for you.